Good morning. Today, the 17th of June 2024. So, I'd like to propose to you the following thought experiment, and I'll leave you with some questions. I'll leave some questions open. Perhaps the mathematics behind what I'll be saying must be worked out properly. So, we have, as you can see in this picture, we have a large processing tower, or well, a large processing unit. It accepts data from an environment and operates on the basis of feedback. So guys, we must not forget feedback on this one. Feedback is a very important feature of the system in question. Now, the um, one of the features of this particular setup is that we get into non-deterministic behavior really easily, since the behavior of the entire system depends on the on factors that come from outside, namely the sensors that receive input from the environment. And you may think you could force the system into a state by feeding it some inputs. Like I remember at Bletchley Park 8 years ago, they managed to break a fragment of German code by bombing a lighthouse, so they could get the name lighthouse written in German in the German's messages. But things may be like that or may not be like that. Things may not be that easy. Okay. So once again, this is a system that operates on feedback, and feedback is everywhere these days. I guess I've supplied you with P equals NP. I've supplied everybody with P equals NP. So everything is really fast these days, or should be really fast. Slippery fast, actually. Yet there's a hidden assumption here. See, I've drawn these sensors that perceive things from the environment. The hidden assumption is that everybody operates on the light of day. So there's, or perhaps, so I'm illustrating this with a light bulb here. So I guess feedback is only possible. Well, a system can get feedback from its internal states, I guess, but feedback from internal states plus the exterior, well, that is actually possible only if we operate with lights on. Okay, so again, there's there's lights on your teenager kids bedroom, then you know they're awake. So yeah, if the lights are turned off, chances are he or she is asleep. So you can choose to turn the lights off and then do things to the system in a certain way, in a certain fashion, perhaps force it into a state, or extract information and so on and so forth, until one can understand more about the system in order to take control. Yet I cannot see an a priori argument for why turning the lights off or keeping the lights on would make any difference. So I guess the question, and guys, the mathematics behind this must be worked out really well. The mathematics behind this must be worked out to a good level of precision. um I guess the question is, does there exist an a priori strategy for the system in question to and the goal of the game is to maintain autonomy, of course. um, does the system in question have an a priori strategy? That is, can it function with both lights on and lights off? So I guess this is an interesting question. One could tackle this problem by estimating how powerful this system is at the current point in time. So one tackles this problem by estimating the order of magnitude of the power of this system, and then what they do is turn the lights off and bombard with inputs, I guess, which can be random or not, or can be exhaustive or not. But I guess the mathematics behind this particular scenario must be worked out to the dot.